Welcome everyone to the Tulsa.net user group. Tonight we got Robert Boedigheimer, a longtime friend and technologist in the field. There's many other great stuff that he's talking to us about, not just HTTP type things, but I believe a previous session that he's done for us was on cryptography, which that recording is available on usergroup.tv. Robert is also a fellow martial artist, so we have a lot of great conversations to discuss in that aspect. So Robert, thank you for being here. Great to have you back. I really appreciate this. And I was just talking to a friend of mine about this talk, the past, present, future of HTTP, and why we need to understand this more. Certainly for things like gRPC requires HTTP 2 and above. And I'm sure you'll probably touch on that a little bit. So hopefully I get some other attendees to help check out this great talk and help us better understand why we need to know about HTTP. So with that, Robert, I'm going to hand this over to you and you take it away.
Sounds good. Thank you. So I won't spend a lot of time on this. I do have my Twitter, my email, and my blog information. So I will have the slides are available. There's a link on the very last slide. While we're doing the talk, I don't mind if you want to put things into chat or if you want to unmute yourself and ask a question, as long as it doesn't derail too much. We'll just take them as they go. Other than that, we'll just get right into it. We'll start way back, HTTP 0.9. So this is from 1991. I gave you a link to where this is actually described. The protocol is described. I'm just going to show it quick, actually, because it's funny the size compared to some of them today. So that was it. So not a lot. But Sir Tim Berners-Lee was working at CERN, and his goal was to make it easier for physicists to share documents. So that's kind of how this started. It was a text-based request and response. There was only a GET, that was the only method you could use, and HTML was the only response type that you would get back. And it would close the connection after every response. So that's the very beginnings. Get into HTTP 1.0. So this came in 1996. I gave you a link to this RFC. They call it an informational RFC, not a standard, because things have been happening since the 0.9 as people were implementing, putting sites online. A lot of people were making improvements to the protocol. So they wanted this to be basically a compilation of best practices, not the other way around, which is let's get a standard and have people do it. They're trying to document what things were doing then. It had request and response headers. You could get any type of response. So the first time you get images, text files, etc. And it's the first time that you could use compression. So that turns out to be very helpful. We had our data center in rural Minnesota. So we were having issues as our sites were growing that we could not get enough bandwidth into our building. So this was our first chance with compression to basically cut nearly half of our bandwidth usage, which was a big deal. And again, I have the links for the RFCs. I recommend that you read them. They're not terribly long. They're not as short as the first one you saw, but they do explain what is supposed to happen. There's no guarantee that that's what every server and browser is doing, but it's very educational to read through. How do the cache headers work? Just all of those things. It's actually pretty readable to look through those. I'm going to show you they kind of made some changes to the RFCs, which I'll get into here in a minute. Right here, I guess. So in June of 2022, now that we had HTTP 1.1, 2, and 3, they looked across all of the standards and said, really the semantics for HTTP and how caching worked were the same across all of those protocols. So they pulled those out into separate RFCs just to make the 1, 1, 2, and 3 smaller and to make the point that they all are behaving the same from a semantic standpoint. It's like, what are the methods? What are the status codes? All of those things are the same. So I gave you the new RFCs here. Back on the slides as you go, I left the original unless you want to see it that way. So you can decide which ones you want to look at. But again, understanding semantics and caching is very useful. And then once you know those, they didn't want to duplicate that in all of the RFCs moving forward. So they just restructured them. Talk about HTTP 1.1 was next. So this was in 1999. And couple additions they made. The first was persistent connections, or keep alives. So what that allowed you to do is, as a client, when you're talking to a given host, you create the initial connection, you know that you may be asking for other resources, so you can specify that you would like that connection to be kept alive. We'll talk a little bit about handshakes and TCP and all those sorts of things. It takes a while to set up those connections. So if you knew that you were going to be making multiple requests, this is the first time you could say, I want to keep this connection to that host to avoid that cost when they make their next request. The next was host headers. So when I worked for a food site, we had a lot of brands. So our internet servers, before this, we were basically burning an IP address for each website on each physical server, because when the client connected to the server would use the IP address to identify what the website was. Host headers were the first time that it's actually communicating from the client to the server saying, this is the specific one I want to look at. So I'm just going to pull up, I'm going to get into Fiddler here in a moment, but I'll just pull this up just to make some of these. So I'm just going to hit Control F5. So I assume most of you have probably used Fiddler, but I just wanted to show some of the, so Fiddler is a tool to trace things between the client and the server. So in case you have not looked at a lot of protocols things before, this is my request for the actual page. And I can go to the inspectors here and I can look at the raw. So this is what we're talking about with headers. So I'm saying I want to do a get for that teledirect page for Fiddler. In this case, it's using HTTP 1.1. This is the host header that we're talking about. So the client for the first time in 1.1 started to say, when you get to that server, that's the specific host that I want to talk to. So then for the first time, we could use a single IP address for all of the brand sites that we had on a physical web server. And then there's a lot of other headers here. And if I go down here, this happens to say that we're using compression. And if I look at this, you'll see it's the same idea. So both, when we talk about a request and response paradigm, this is the request. Here are the various headers that tell the server about things like you can handle compression, you want this to be in US English, what your user agent is, which is a big lie, right? They all list everybody. And then down here is the response to the same idea. I'm going to get some specific things sent back as a response header. And then you see the normal content down here below. So the other note about 1.1, so this started in 1999. If you think about this, so I started doing websites, I believe, in around 96. That stayed the same for a really long time. It's not very often that you have something that was designed this long ago. I mean, that went from 1999. We'll see HTTP2 was around 2015. It ran for a long time and it was a huge success. So I'm not trying to diss HTTP 1.1. I'll talk about some issues that it had and improvements that were made going forward. But just remember that a lot of things were sold and a lot of people found great value in the web just using HTTP 1.1. We do want to talk about some of the problems though. So some of the problems with this is the protocol was not designed for the type of web applications and pages that we started to make. So if you're familiar with HTTP archive, I'll just pop out there quick as well. So they visit a ton of websites and they have documentation on statistics basically about HTTP. So this is the total K size of the average pages. So you can see we're up a little bit above 2 meg. And if I come out here and look at requests, we'll see that typically around 71 requests. So again, this is not really what the protocol was set up to do. So we had to start working on things to basically tolerate or work around some of the limitations of 1.1. So the problems we'll go over, it requires multiple connections. It has what's called head of line blocking. There's a lack of prioritization, and there's also very verbose headers. So we'll just look at these one by one. So the first one is it requires multiple connections. So in the spec, it says that a browser should open up 2 TCP connections per host. And on that given connection, you can only have one pending request and response. So in theory, when you're talking about getting 75 resources, you're supposed to use 2 connections and you can only do 1 at a time. So essentially on each connection. So you've got basically 2 things can be going on at the same time, whether that's CSS files or images, whatever. So most browser vendors figured out after not too long that if they added more connections, they would look faster, or they could do things more in parallel. And today, if you do the traces, and I'll show you, we'll see this here in a minute, most browsers use 6 connections. The bad news about that is it uses resources. So each connection takes some resources to manage. And also it takes time to establish and be efficient with TCP handshakes. So the way TCP works, it's a 3-way handshake. So basically the client will say SYN, the server will send back a SYN-ACK, and then the client will send a client hello. So it's basically a back and forth. So to the server, back to the client, back to the server to get the TCP connection established. The other thing is TCP uses what's called slow start. So TCP has been around a lot longer than HTTP. And what TCP said is that it was designed during an era of very problematic internet connections. So they have what's called a slow start. So when you first start a TCP connection, as a client, you send a small amount of data first. The server will acknowledge that, and then you gradually add to the size, like you grow into sending more data. So the bad news with this, like we said, it does a 3-way handshake, and it starts kind of slow before it's really taking advantage of how fast it could transmit data, and it's doing that basically times 6. So that's the first problem. The next one is they have what's called head of line blocking. So we talked about there's a single serial request and response per connection. So what happens is the browser gets your HTML, it's got one connection. It sees it needs to get a bunch of CSS and images and JavaScript. So it starts downloading those on and creating those other 5 connections. I'm going to have 6 connections going. The problem is on a single connection because it's waiting for only one resource per connection. If that is slow for some reason, you've burned that whole connection. In other words, if there's an issue, you could basically be down 1/6 of your capacity because it will be stuck. So I'm going to show you an example of this. As a note, they tried to solve it. Years ago, they tried to come up with HTTP pipelining, which let you submit multiple requests, but it never really worked well and didn't take off. So let's look at head of line blocking here. So I'm just going to clear what I have here now. And in Fiddler, one of the features I like is the autoresponder. So I basically have set up a page here to show you, I've got a really simple web page. It has 6 requests for images with different query string. And then it's got a couple additional JPEGs. So if you think of this and what HTTP 1.1 will do, it's going to get the HTML, and then it will use up those 6 connections for these 6 images. Then it's going to have to wait for those to finish before it can start getting these 3. So one of the things I like about Fiddler, I can make things intentionally slow. So if you look at this rule, it basically says if you see images 1_sm.jpg, purposely slow it to take 15 seconds because I want to be able to demonstrate how that burns connections. So if I come back over here, I think I'm going to do a quick Control F5 here. You can see some of it. You can see that it pulled a few, but now it's sitting waiting because I intentionally delayed these. So those other images that should be able to get are all held up. Now you can see that those finish and then it eventually gets these other ones. I'm going to do that one more time and hit Control F5 so I can. So here you can see 1, 2, 3, 4, 5, 6. Those are my 6 connections to that host, and they're all now burned. And I want to get these other resources, but essentially because those were stuck, the head of line blocking, these had to finish before it could even ask for these others. So that's one of the major drawbacks of 1.1. Next one is lack of prioritization. So there's no way for me as a developer to say, there's no direct way for me to specify, here's exactly the order I want you to use to go get my things. So browsers need to decide how they're going to best use those 6 connections, right? So most of the browsers, they all differ slightly, but most of them are going to try to get CSS early, then JavaScript, then images. There have been some changes lately for performance and things where you can do some fetching with priority and other things. But from a protocol standpoint, there was no way for the client to indicate, I want you to for sure get my JavaScript first for whatever reason. So that's just not something you could do. Next one is verbose headers. So we looked at the headers that got sent back and forth. So the first problem was they never compressed the headers. So I showed you that I was compressing the response. That's great. HTML and text-based things usually will compress to anywhere from 50 to 75% smaller, which is great for performance. The headers themselves were never compressed. So we'll take a look at some of the things being sent back and forth, and it's just unfortunate that compression exists and they chose not to use it for the headers. The other thing is they repeat headers for multiple requests to the same host. So if I pop back over here, we'll just look at this one, will work as well as any other. If I get my inspector back, try to make that a little bigger. So you can see I did the get for the head of line blocking. I said I want to keep alive, caching. I say again what my user agent is. I talk about that I can accept this for compression, the language. So that's great. I've communicated that from the client to the server. Unfortunately, if I go back down on any of these other ones, all of that information is being sent with every request. And so that communication is just wasting. Now, I see it a lot with cookies. If you end up having a lot of cookies for your host, it's going to send a lot of data. And unfortunately, it's sending it for every request. So that's another negative from a 1.1 perspective. Talk about some terms. So bandwidth. So I got some weird looks when I did this at the hardware store, but I took some various sized pipes. So that's how you think about bandwidth, right? It's measured in units of bits per second. And it expresses how much I can send down that pipe at any instant. Obviously, I can push more stuff through the one on the right than the one on the left. I said it's relatively easy to add more. So in most areas, there's quite a, it varies a lot what you could get from the lowest bandwidth you could purchase to the most. So in general, typically you can go ask for more. It's not that hard to go get a bigger pipe. If you talk about latency, so latency is measured in milliseconds, and this is the time. So when I send from a client to a server, it's the time it takes for the packet to get to the destination and typically coming back. Extremely difficult to improve. So in other words, it's mostly, and I listed out the 3 parts of what usually leads to your latency. Propagation is based on the distance. So it's hard to make Tulsa be closer to Minnesota than it is, right? I'm not going to have a lot of control over the distance impact. So what you want to do instead of your improvement on this is you try to avoid latency. And I'll show you an example where they did some research on this. So this is not a joke. It'll sound like a joke, but 2 Google developers were in a bar and they got into this argument. Which one matters most, bandwidth or latency? All you ever hear when you go to an ISP, they're telling you what the bandwidth is, 100 megabits per second, 250, whatever it is. That's all they ever try to sell people on, is that it's the bandwidth that matters. So they decided to do a controlled experiment. And they said, we're going to make the bandwidth better, like we'll add a megabit per second at a time. They took a typical website, so we're not looking at streaming video, those kinds of things. Typical websites, typical resources, CSS images, and they measured each time they added more bandwidth, what kind of impact did it have on the page load time. And you can see at first, it helps a lot, but it eventually gets down to just a single-digit percent perf improvement after about 5 megabits per second. So for the typical sites, it really doesn't matter what the rest of this is. It's not as impactful. However, they cut the latency. So if you look here, they had to introduce some latency so they could control how long it took to talk to the server and back. And by doing that 20 milliseconds, they're basically getting a linear improvement in page load time. So again, this just pointed out for most sites, it's really latency you need to be concerned about. I did give you a link. You can go read about that. It's got a lot of the details about how they did that, but this influenced a lot of the rest of the things we're going to talk about. So as we said, one of the big goals for HTTP2 was we want to minimize the impact of latency. We can't make it go away. So let's try to do things that will minimize its impact on site loading. They want to avoid the head of line blocking that we saw. They wanted to use a single connection per host. So rather than have 6 separate connections open, they wanted to have a single connection, and they wanted to use that connection for all of the resources. So we'll talk about that with multiplexing and such. The other important thing is they said we need to keep HTTP 1.1 semantics. In other words, the way methods are used, statuses, headers. They felt if they started to play around with those things, it'd be very hard to get HTTP2 adopted. So they looked and said, they don't see a lot of problems like what was chosen for status codes isn't holding anybody back, right? So rather than go tweak that whole thing, they said, let's keep that as it is. So the good news about that, when you went from 1.1 to 2, you didn't have to change your application code because all of the semantics and everything else was the same. That wasn't a concern, which really helped adoption. You should, however, remove some current workarounds. So I've been doing performance talks for many, many years. And a lot of the things that I would have told you in the HTTP 1.1 days just don't make sense for 2 and 3. So I'm going to go into that in some detail later in the talk. But the good news is going from 1.1 to 2 or even to 3, you're not going to have to change your application code. So HTTP2 or H2, people get sick of saying HTTP2. Came out in 2015 is when it was standardized. Gave you a link there to the RFC. These are the major categories of things that they worked on. So I'll touch on each of them really briefly, and then we'll get into the detail about a couple of them. So the first was HTTP 1.1 and older was text-based. And now in H2, they're doing binary framing layer. The next is they have streams. So they wanted to create streams. So now that you have a single connection, they wanted to be able to send multiple resources down. And they wanted you to be able to do some prioritization. So they wanted you to have more control over which specific things were important. I've struck some of these things out. These were the goals, and some of them did not work out real well. And so I believe Chrome's already pulled out the prioritization, and I'll get to the server push in a minute. The big change that gives most of the benefits is the fully multiplexed on a single TCP connection. So now you only need to spend the time getting one connection with a handshake, getting it up to speed, like getting through that slow start, and then everything you're communicating with that host will be going over that single connection. So that was the huge improvement over the 6 connections and the approach that was used before. They added header compression. So we talked about how that wasn't there, and I'll show you the details of that one. Server push sounded kind of entertaining when it started. So the concept is the client comes to the server, you get my HTML. This, let's say you've never been there before, you're going to get all my CSS, JavaScript, images and stuff. With server push, if I see you make a connection for the HTML, what's going to happen after that is as soon as that finishes, I'm going to send it to you. You're going to parse it, and then you're going to start asking me to get the CSS, JavaScript, and everything else. So the concept was, why don't we have the server actively push that stuff to the client so it starts downloading rather than wait for the client to parse and come and ask for it. And so the theory, and there were This is one of the areas that people really focused on when H2 came out. They really thought this would be a lot of big wins. Some of the problems were you might already have stuff cached. So if you've been here before, if I start pushing CSS and JavaScript and stuff to you right away, I might be sending something to you that you already have. Now, they had a mechanism to get out of that, to say, stop pushing this stuff to me. But it was just not perfect that I'm pushing you all of the stuff and potentially using data when you're not even going to want it. That and a whole lot of other problems is server push has been pretty much retracted or pulled back as well. The other problem I had with it personally is it wasn't surfaced well to me. I'm an ASP.NET developer. There wasn't a good way for me to indicate what things I wanted to have pushed. So that was the other struggle. So again, we're just going to focus on the multiplexed and the header compression. So I am no artist, so bear with me here. But this is the single connection. Again, it's per host. So each host you have will be in this scenario. So I have my client. You can imagine this connection. And the idea here is I've got a number of different streams. So a stream in this instance is just a request response. So here is, maybe this is my logo, right? On that connection, I'm just going to be taking various files that are prioritized that I want to get down to the client. And as I have them, I can just shove them all together like this and intermix them on that one single connection. So again, the good news, it uses less resources. I'm not burning memory for 6 connections and everything else. So this, but going down to the single connection is by far the best feature. And it's also why we'll make some changes later when we talk about things you shouldn't do anymore. But from a picture standpoint, that's the advantage. And again, it's per host. They created header compression. So on normal compression, if you saw before, it's like deflate, gzip, Brotli's one of the new ones. When they first started, they said, why don't we just use the same compression we use everywhere for the stuff that's in the header? And I don't go into it in detail here. I believe the acronym is CRIME. There were exploits that people could take advantage of because of how those compression techniques were used for headers. So it gets into a lot of gory details I'm not going to get into here. Essentially, the security stuff, when they first used regular compression, they had to pull that back. So they said, let's just come up with a new way to compress headers, which is called HPAC. It's got this different RFC. So the idea was there are common headers. So if you look at a normal conversation client to server, things like accept encoding, accept languages, there's things that are sent all the time. I want to do a get, or I want to do a post, or here's the status code. So they made up 2 different areas for header compression. The first is there's a static table of predefined common headers. So I'll show you that. For instance, if I want to do a get, instead of saying get, I'm going to index a specific value. And then there's a lot of headers that are not going to be very consistent. So in that case, there's also a dynamic table that stores that stuff. So this will make more sense when you see this picture. So I'll just jump to this. On the left, I'm doing a request. It's a get. And so that happens to map to the number 2. So in other words, instead of having to put out that full, I can just say I want 2 HTTP, which I should change this because you never just use HTTP, it should be HTTPS, happens to be 6. The root folder happens to be 4. The user agent, this string is well known, so it's a 58, but there are tons of actual user agent values. So they don't try to pre-guess and have a number that corresponds to this, but they use what's called Huffman encoding just to make it use less bits or bytes. So you can see over here, just a little smaller. So I'm saving space on these because I'm just referring to the well-known ones, as you can see, by number. And then the ones that have specific values, at least they're smaller because they are Huffman encoding them rather than sending them just as normal text. So you can see that through here. So these first ones are all well known. Now here, I'm just giving an example if you used a custom header. So I made up that I have this RJB-HDR header and a value that will start to use the dynamic table. So it says 63 is now going to be this, 64 is going to be that. If you keep sending that for your next requests, you don't have to send those. So that's not only is it compressed, but they said, why do we keep sending these things to the same host, especially now that you have a single connection? Stop sending them if they haven't changed. So on the very first request, again, you'll see this. And on the second request, whatever has not changed, like your user agent isn't just going to flip during the middle of your conversation. So you don't have to send any of that again. Now the server and the client, it introduces some statefulness to the protocol. And so just be aware, before it was always stateless, this compression has benefits from a performance standpoint, but it does need to store a little data about your specific connection between client and server, because it's not going to keep sending this stuff every time, if that makes sense. There was a big fight over requiring HTTPS that went on during the standards for quite a while. In the end, it was not required. So if you actually look at the HTTP2 RFC, it is not listed as a requirement. They did say, however, if you use HTTPS, it has to be TLS 1.2 or above. So if you're familiar, HTTPS is just, I want to send things encrypted. It's basically HTTP built on a secure channel. Used to be SSL, now it's TLS. And for PCI and other compliance, you should be using TLS 1.2 or above anyways. So they said, you don't have to use HTTPS, but if you do, you have to use 1.2, and they took some of the weak cipher sets out as well. Like even though you're using TLS 1.2, you can't use, I'll make up like DES from a cryptography standpoint. So they just took out some of the cipher suites that were not secure. However, so that was to get things signed and agreed, they needed to do that. However, the browser vendors said, I don't care. We won't use 2 if you don't use HTTPS. So the browser started making that rule. So effectively, it's not in the spec, but you don't really have a choice. The reasons that they gave, so during HTTP2, Google was out front doing a lot of testing. They found that, first of all, they thought it should use HTTPS, and it should. If you follow Troy Hunt for Have I Been Pwned, his site for data breaches and such, he was having a conversation with somebody, and this was years ago, that was still arguing with him that my site does not need to use HTTPS. It's nothing important. People can't mess with it. I'm not concerned. So Troy asked, do you mind if I use your site as an example then for how you would have problems? And amazingly, of course, they said, sure. And it's hilarious if you go out and look at it. He didn't compromise the server. He was just showing how you could intercept the traffic, make modifications, and really mess with what happens on the client. So slight diversion there. You should use HTTPS for everything. They found that when they were starting to do HTTP2, I think it was only 75 or 80% of their communication would work when they tried to not use HTTPS. And the reason was there are a lot of what they call middle boxes on the web, right? Proxy servers, firewalls, they all look at this traffic, and if it's not encrypted, they would look and see new things that were HTTP2 that they didn't understand. And some of them would freak out. So basically those machines were making it difficult to roll out the new protocol because they were sitting looking at stuff that they didn't understand that was impactful. So not just security, but having it function. They decided that we just have to use HTTPS for that. So we talked about some of the problems with HTTP2. The first was server push and prioritization have basically both been considered a failure. So they are not something you'll find in current implementations. And the other problem with it is TCP limitations. So back when they did HTTP2, They wanted to fix the latency. They did all they could do. And now they got to the point where they felt they did as much improvements as they could do without, with TCP still being there. So with TCP being there, you can still have these problems. So the first one, when I talked about head of line blocking before, was at the HTTP level. That still happens at TCP level as well. So if you use TCP, it's connection oriented. If you have a packet that needs to get retransmitted, even though HTTP2 is trying to use that one connection, if it does retransmissions on that connection, everything is going to be delayed. So TCP, that's still a problem at that transport layer. They also had the three-way handshake, and they also had the TCP slow start. So those are the things they wanted to work on. I do want to do a quick demo here, though, of some of the speed differences. So I kind of hate this demo. I kind of don't. So I'll explain why. I'm first going to show you. So I use the new Edge HTTPS. This is one of the cool features. I normally have this on, automatically switch all of my connections to use HTTPS. So even when I don't type it, it's going to force HTTPS. There's a few sites that are HTTP that'll mess up. That's okay. They'll show me on the screen, we can't do with HTTPS. Do you still want to go there anyways? Which typically I wouldn't, but for this demo, I need to actually shut this off. So let's just see the speed difference here. I'm gonna do one thing. Didn't mention this yet either. There's two Fiddlers now. So I've used Fiddler Classic for more than a decade. It does not support HTTP2. So Telerik bought Fiddler. This is now called Fiddler Classic. It runs on Windows. They're not putting more money into enhancing Fiddler Classic. So this does not support HTTP2. So when I went to go run this test, it just warned me, hey, your browser doesn't support HTTP2. That was actually because I had Fiddler in between. So I'm just going to shut that off. The other one, as long as I'm talking about it, is Fiddler Everywhere. And it's a rewrite of Fiddler cross-platform. So it runs on Mac, Linux, and Windows. And they've been slowly adding features to get it up to par at some point with Fiddler Classic. Be aware that's a subscription, but if you need cross-platform tracing, that you might want to do that. So now that I have Fiddler off, I'm going to run this again. Just going to do a Control F5. So if you look at what they're actually testing, they say HTTP versus HTTPS, and HTTP to get all this stuff was 2.7. If you do HTTPS, if I were to ask you ahead of time, do you think the encrypted will be slower or faster? You would guess slower. So if I click on this, wow, that's odd, right? 76% faster. It's because with HTTPS, this site and browser will use HTTP2. They won't do that if you're not using the security as we talked about. So because they have the single connection, I'm just going to hit Control F5 here again. It's downloading all those check marks in parallel. So you don't have that 6 connection. If I flip it back to HTTP, you'll see them kind of come in sets here. And that's because you only have the 6 connections to play with. So it is faster. It's a demo. I don't have a web page that has 360 check marks on it, right? And you probably don't either. So it's a little skewed, obviously, to show the difference. Generally, you won't see that big of a performance improvement because you don't have quite that drastic of a difference as far as what's actually on that page, if that makes sense. I didn't mention it. I just saw it when I was going in here that can I use? If you've never been out here before, can I use lets you look up protocols, HTML, CSS3. You can basically put in here, I have a web-based technology that I want to see how well it's supported across different devices. So in this case, you can just come out here and look by browser, by version, how well is H2 supported. So it'll tell me whether it's supported yet or not. It just helps me make decisions about, is it ready for me to adopt it? How would I do things if I had to do a fallback, etc. So if you've never seen this before, this is useful to look at. So we'll pause quick in case anybody had any questions on anything yet so far. I don't know if there's any chat or anybody before we get into HTTP3.
No questions yet, but the demo was really cool. And I had seen something similar about, but I'd forgotten about it. So it was really neat to see that again, the difference between the 6 pipes, the 6 connections, if you will, and the way that HTTP2 handles that. So no, that's fantastic.
Cool. All right, so we'll get into, I'll say H3 because that's just easier. This was standardized 2022, and I gave you the link for the RFC there. And I just wanted to put up the stacks, kind of I was watching Schwan's network fundamentals today when he had an OSI model and the typical stacks and things you tend to line up. So I just wanted to show the difference between HTTP2 and 3. So on the left, H2, you can use TLS, right? Again, it's not required. It's effectively required because the browsers make you. That sits on top of TCP. I was talking before the meeting about Douglas Comer's TCP IP books and that I read many, many years ago. But TCP is a connection-oriented, and it tries to ensure delivery, proper ordering, all that stuff is built into TCP. So those kinds of features don't have to be implemented by H2. That's just part of the support you get by being connection-oriented with TCP. And then that, of course, runs on IP, and you've got physical layers underneath. The difference with H3 is they said, we've squeezed as much as we can out of TCP and having it be a connection-oriented. They said, we want to swap out the transport layer. So now what they did with H3, underneath it, that started with what's called Quick. So that is the new connection-oriented reliability sort of layer for H3. It will only use TLS 1.3, so you have to use HTTPS going forward with that, which I think is great. That, however, is built on top of UDP, which is a connectionless. So you can see some of the differences here for size. TCP offered a few more features to the above than UDP since it's not connection oriented. So Quick had to re-implement some of those things, but in a more web specific way. In other words, they do things for the web that a general thing like TCP might not be able to do. So that's why you see from a size, UDP is smaller than TCP in general. Quick has to be a little bit bigger because it needs to re-implement some of those things. And then HTTP 3 and 2 are essentially the same. You can think about H3 as it's really just a mapping for HTTP sitting on top of Quick. Now, because Quick does a lot of things HTTP 2 used to have to do, that stuff got removed from 3. So if you ever look at the specs, 3 as a spec is smaller because more of the things have been pushed down into the Quick transport layer, if that makes sense. So those are the high-level differences, but this is really, when you talk about H3, it's not really any changes. Again, the status codes, all those things are exactly the same. It's just now using Quick on top of UDP. So we'll talk about Quick. A couple cool things with this. It has a 1 round trip connection establishment. So when we talked before about the handshake, I thought I had maybe a diagram in here. Probably have one just to see some of the typical handshakes that go on. Okay, so here's a quick view of some of the other handshakes and such, but the TCP IP, the TCP, the TLS, HTTP2, it would be this. TLS 1.3 made that connection 1 less round trip in general. So just from going to 1.3 from 1.2, you have 1 less back and forth to set up the encrypted channel, which, by the way, again, for perf stuff, I turned that on one day. I wanted it to be better security for browsers that supported it, but my site got 20% faster because of not needing to do this stuff. There's not many times in the performance world you can click a check mark and get 20% faster. So just so you know, enable that because most clients support it and you'll get that 1 less back and forth. So when we talked about latency before, high latency environments, these back and forth just kill the performance. So you're going to improve it if you have a lot of people using high latency. This is a big improvement, just what TLS did. Now, if you look at what Quick does, the way they establish the initial connection, they do the Quick and the TLS at the same time, and then they're already talking. So it's just, you can see as we progress, there's just less back and forth needed for these things. They also have a 0 round trip. And so one of the exciting things people are looking at is if you connected to my server previously and established a quick connection with TLS 1.3, the client can keep some of that information. So on subsequent reconnects to me, you may be able to immediately start talking to the server without any round trip at all. So just be aware that's one of the highly touted. We'll see how well that works out practically, but that's one of the big on paper advantages. It's always encrypted, so we'll get out of these debates about should this be encrypted or not. It will be encrypted. The next things that they can do, they have what's called connection migration. So if you think you're on your phone, you're at work, you're on a Wi-Fi, you have your connection, you're doing something with a website, you walk out to your car, you're suddenly outside of your Wi-Fi range and you flip over to start doing things on cellular. Quick has the ability to actually migrate your connection from the Wi-Fi to the cellular. So TCP is just too tuned into all the way the connections are set up and stuff. You're just stuck. When you leave the Wi-Fi to go to cellular, you're done. You're going to have to reestablish a connection. The Quick will do migration of that. So it has more logical connection identifiers. So that's one of the other things that people are excited about is the potential to be able to cross over different networks, but still keep your existing connection open, which is cool.
I had a quick question on that. So, I mean,
to me, Quick, he even got the name in there. Nice.
That was purely unintentional aside from all my slappy jokes in the chat. It sounds to me like Quick is an alternative because I mean, TCP is just packets back and forth with a protocol. It sounds like Quick is just another overlay protocol on top of UDP that's for modern networks that change all over the place.
Yeah, so for this picture, and we'll get into some of the bad parts. I mean, the limitations of TCP is where they finally just said, we're going to go flip it to use a connection-oriented underlaying because we want to rewrite. So they do all the congestion control, all that junk that was built into TCP back in, I think I saw the date today, like 1981 or whenever that was created, was a long time ago, right? Those things are just not working out so well. So by doing it on the non-connection, the datagram sort of UDP, they've just rewritten some of the things they don't like about that layer, if that makes sense.
Yeah, it does. This diagram helps more because again,
yep,
those things don't go away. It's just they can do it more efficiently.
Yep. So if we're on this stack, yeah, like you said, I mean, all the same problems are there, right? I mean, you still have to deal with congestion control. You still have to do the reliability. You want to know that people get things, right? You just don't want to have to stack it on top of something that has fundamental limitations in some of those areas that you can't avoid, if that makes sense. So
there's a question in the chat about data loss, and I think what I've asked and what was just asked in the chat go hand in hand. You might address that. I can read the questions since I'm already talking and Sean's
sure.
But I'm already speaking. It says, with data loss, can this be used in manufacturing?
Well, so I don't want to act like H3 is data loss. You still have the reliability you expect. You're just not getting it from TCP. You're getting it from Quick. So the fact that Quick uses UDP, which is not, reliable, it's not connection oriented. Both these application layers see what's below them as reliable and connection oriented. They're just rewriting the kind of archaic congestion control and other things they get to do over. So I didn't mean to say that either one of these, it's not like just because H3 is sitting on UDP, that it's the Wild West, things are coming out of order, things are not being sent. That's not the case. They both have reliable transports below them. This is just a more modern implementation sitting on what, because they don't want to tweak this. They basically looked at TCP and said, if you think switching HTTP would have been problematic, you start farting around with TCP and changing fundamental things in that, you're going to break a lot of stuff. So they decided rather than try to tackle that, we will just create Quick the way we want it. but it still has to run, right? It still has to run on things that exist. So they had to get rid of TCP, so they chose UDP and then wrote the reliability and stuff in quick. Does that help? So it's not, yeah, don't think of it as it's suddenly not reliable. It is. It's just implemented in a different place. So I don't know if that helps. So the other thing about Quick, at least for now, most of the Quick implementations are in user space. So again, if you've done networking and things, the transition from user space where our applications lived into kernel space, TCP and all of those things have been implemented typically in kernels of operating systems, so they're fast. Quick, so far, the implementations have typically been in user space. So you have a transition issue there. The advantages of that, it's more flexible and you can change it more often. You don't have to roll out OS upgrades, and you can also choose an implementation that you want. In other words, I can look and say, I want, like Microsoft has their own Quick implementation. If I looked at it and said, I love theirs, I don't like this other one, I can swap out the Quick implementation for Microsoft's. That's something that would be hard to do. You know, I want to swap out the TCP layer is much harder to do. When it's in user space, they say they'll have more flexibility. It'll be easier to modify. The trade-off is the performance concerns. And so I've got a lot of backing for this from research things, and they say that Quick does use more CPU, and it's because being in user space, it's just more taxing on stuff. They think that as that stabilizes, people will start to do kernel-based implementations of that to get the speed once they get through kind of the, let's run this for a while, it's going to have a lot of churn. But that's just something to be aware of. And then they wanted to use HPAC compression, which is what they made for H2. That had some other issue with it, so they basically had to rewrite compression yet again, which is called QPAC as far as the protocol for that. So a couple notes, looking forward to H3. So I should have said, by the way, I didn't mention it. It was great for me. I use a CDN. And so when I was using HTTP1 and I wanted to go to H2, I came back, of course, within my company and said, can we do H2? We didn't have the Windows server version that we wanted to run H2. It takes a while to get companies to switch those kinds of things. Because I was using a CDN, you make a request for my ASP.NET page, you get my HTML, all the other JavaScripts, yet all those things I store on a CDN. So because the CDNs are very aggressively going after new things, I went and turned on H2 at my CDN level, which is where I was going to get the most benefit. You only make one connection to me to get my HTML. Everything else is on my CDN. So the ability to make that be faster, and it was out there and had been used a lot by other people, was a big advantage for me. It's a good way for me to be able to implement it. And like I said, it gave me virtually all the benefits because you only get one thing from my server anyways. HTTP3. So I've been using H2 for a long time. I'm not using 3 yet. This is something I'm still working on. So I don't have all the, this happened when I did this as much because we haven't switched this yet. One of the problems with connection establishment, a browser now comes to a server. Is it going to use TCP or is it going to try to use Quick? It doesn't know, right? So there's a connection establishment issue that the first time, so if you turn on H3, most of the implementations are saying, browsers come to me first using H2 and TCP. I will send you back this response header called alt service. If I support H3, I'm going to send you back a header that says, by the way, I do H3 over here on this other port. Please use it for future connections. And then there's all sorts of, will the browser always use it? If I show you some of the traces, and I'll just show you here quick with, that's not what I wanted. I'm just going to go out to Cloudflare because they're aggressive on HTTP3. So you can see here, I can see the protocols. If I cleared my cache, I believe it's a cache sort of thing where they're storing that. You'll often see the first connection will be an H2 because the browser has to make a guess, right? Unless it's pretty confident that you're using H3, it doesn't want to connect and get denied. And so some of the other people were saying, why don't you start up both? Do a TCP and a quick, whichever one you get an answer to first, keep using it. And they've decided this alt service is probably the best approach people are going to do. So just be aware when you're tracing, even though you have 3 support turned on, it may take your browser a while to figure that out. And I've done a number of traces where I did what I just showed you. And some of them start in H2. And then when they go to get other resources, they switch to H3. Some of the other ones were just, I'm going to use H2 for this whole conversation. I'll just squirrel away that alt service the next time you come. I'll just try H3 right away. So you'll see some variance in whether it flips to H3 halfway through, after 1 connect, 2 connects. And again, this is per host, so these may be on different hosts. But just be aware that does cause a bit of a problem for the client browser because it's either TCP or quick, and it's not sure which one it should use, if that makes sense. As I said, there is some CPU impact. They're blaming it mostly on being in user space rather than kernel. About 2 times more for quick. I don't know if that equates to, like if I looked at my web server today and I'm at 25%, I don't know if that means immediately I'm at 50. Again, I haven't turned this on yet. They're just warning that that is the one performance or server utilization impact of switching to quick. The other problem is UDP, because a lot of firewalls and people have been using primarily TCP for connections. UDP has had less focus and optimizations over the years, and they say it's often blocked. So as people roll this out, we're going to have to see, what are they going to do when they run into UDP issues? Because like I said, they've been doing everything on TCP for years and know how that works. The UDP stuff for this kind of reliability built on top of it is just a little different approach. So they're curious about how well that's going to work out, if that makes sense. So those are some of the things you're going to know. Yep.
Yeah, we got a question in the chat.
Okay.
If we set up gRPC in .NET 7 to use HTTP 3 and the browser doesn't support it, would it be all or nothing, or would it switch to HTTP 2 by default?
All the ones that I've heard auto downgrade. I should have mentioned that before, so I'm glad you asked. So that was the other thing when we rolled out from a browser, even when we had 1.1 and wanted to go to 2, it wasn't like everybody, we went to can I use, most people supported it or enough. If the browser tried 2 and it didn't work, they do 1.1. I mean, nice. It downgrades. I have not played with it in .NET yet. I know that I have a bunch of research things under my other one here that talk about some of the implementations, and it gets into like the .NET and 3 support in .NET 6 and what you can get in Windows Server and stuff. I have not tried them yet, but I would be shocked if you tried 3, it didn't fall back to 2. It doesn't seem to me like something you'd have to code around. It'd be something that the library or framework would support falling back if it wasn't there. That makes sense?
Yeah. All right. Thank you.
Yep. So let's talk about some of the workarounds. So these are all the things that, like I said, I've been doing performance talks forever too. In 1.1, and these are all basically because of the 6 connection versus 1. So in the 1.1 days, we did bundling. So you probably know what minification is. You should always do that. It takes out the white space and it just gets it to be smaller. But there were a lot of recommendations that if you took all of your JavaScript files and bundled them into a single file, that worked better when you only had 6 connections rather than getting 15 different JavaScript files. So we did our minification, we did our bundling. I turned it on, then the next day my homepage was 50% faster, which again, it wasn't a lot of work to do minification and bundling. So that was a huge improvement. Now with 2 and 3, I got to see how I want to word this carefully. The single connection makes it where making additional requests is not the kind of penalty that it was before. I'm not saying go request everything willy-nilly, but look back now and say, I probably don't want to bundle all of my stuff into a single JavaScript file. Bundling was easy, tools support it. The problem is I cache that, I tell it to be cached by browser for a year. Now I change a single thing in a single JavaScript file and your whole bundle gets invalidated, which is a little unfortunate. So there's still some debate on this. People are not saying don't ever bundle and just go back to every JavaScript file you need, just go ask for it. There's a lot of research on what's better. They say it gets a little better compression and stuff if you still have larger JavaScript files. So they're saying more bundle by area. So like if you have CSS or JavaScript that's used just in checkout or whatever, bundle those together. So they're not saying swing completely the other way, but putting them into a single file probably doesn't make sense anymore if you're using 2 or 3. Same with CSS. So we bundled our CSS into a single file, worked great. About a month later, did our next release. Everything was fine on every browser but Internet Explorer. And I was using Fiddler and doing breakpoints and changing CSS files and doing all this stuff. And I came across the fact that it was a size limitation. So I went and looked, an undocumented feature in Internet Explorer, you couldn't have more than 4,096 unique styles in a style sheet. Thank you, Microsoft. So bundling that, so we had to break it into smaller files. So again, the point is just bundling is not something you just have to try to get down to one file like you did before. Same with CSS sprites. So a CSS sprite is people would take lots of, if you had a lot of small like icon files and small things, they would put all those into a single image. If you've ever done a trace and you see an image that comes back that has like 30 logos in it or small images, they basically would shove all these small images into a single image, and they would use CSS to index basically just the one you want out of the one that was shoved together. Again, it was to reduce requests. It worked great. CSS sprites kind of suck because now you need one more and you have to like rebuild your whole thing and change your CSS. And so it's not very fun. So don't do it if you're only doing it to cut down the number of requests. Next one was domain sharding. So my website, I have, I'll use www.example.com, right? I have cdn.example.com. I get 6 connections for that in 1.1. But if I use cdn1.example.com, now I get 12, right? Because each new host name I come up with gets 6 new connections. So people did that to get more parallel downloads, basically. It wasn't great because they have slow start, all the other issues. And also, so I looked at it, my site would have been 20% faster if I did this. But the problem was I'd have to have a rule to say, go get logo, always off of cdn.example.com. I'd have to basically have a rule about which name to use for a certain file. If I didn't do that, if I coded it with cdnexample.com/logo.svg, developer 2 uses cdn1.logo.svg, you had it cached when you came yesterday because it had my name on it. Now there's another page that references with the other domain. And so you have to re-download the whole thing again. So it was just too problematic for me. It gave me 20%, but it would have sucked to try to get everybody to follow those rules. So I just didn't do it. So don't shard like that because you don't need to get another set of 6 connections with 2 or 3. And then the last one is inlining. If you've ever heard of data URIs, you can take small images, base64 encode them and put them directly into the HTML. And people would do this for small images just to avoid that second request. Probably doesn't make sense now. Same with CSS, although I put, it's not a perf talk, so I won't spend a lot of time on it, but people who are really serious about performance will do what they call critical CSS. They'll look at their big set of style sheets. They'll pull out just what they need for the above the fold on the first page you're on. They'll split their CSS to be the critical things needed to make that not look horrible. And then the rest of the CSS they download in the background. They'll inline that critical CSS into the HTML because you don't have to wait for the file to be downloaded to start rendering things. Critical CSS, I would agree, putting it inline is still okay. Any other inlining of any other CSS just to reduce requests doesn't make sense. And same for JavaScript, like shoving it in to the HTML solely to cut requests doesn't make sense. And this all just rolls back to, we have a single connection, so that's not that big a deal anymore. That makes sense?
Yes, it does.
So
Any questions?
Yep, so there's Twitter and email and blog, and there's the link to the slides, and then just fire away.
Awesome. Does anyone have any questions for Robert? You're more than welcome to either come off mute or ask him in chat. I'm typing in right now the URL. So 343-567. Helps if I spellificate correctly. Okay. All right. Don't see any questions in chat. Robert, thank you. This was awesome.
Welcome. Thanks for having me.
Yeah, of course. And I like the demo too. Like I said, seeing the 6 limitations of the 6 sockets versus when it's just open to do its thing. So, and also like the kind of showing some things to watch out for. I think that is extremely helpful as well. So thank you, man. I appreciate it.
Yeah, you're welcome.
All right. I guess we don't have any questions right at the moment. So what I'll do is I'll go ahead and stop the recording.